Good day to Doctor and everyone. We are from Group 4 and will be presenting on the production of cheddar cheese. The group members are Kayen, Susan, Zeshuen, Adam, Najiha, and me, Jamie. Today's presentation will be looking into the overall process of cheddar cheese production, its upstream and downstream processes, and waste management. So, what is cheese? Cheese is a solid concentrated milk product consists mostly of protein, casein, and fats. Currently, there are more than 2,000 varieties of cheese being produced in a wide range of flavor, texture, and shapes. Cheese can be classified into three groups based on its moisture content, which are hard cheese with the lowest moisture content, semi-hard, and soft cheese. Cheddar cheese is a type of hard cheese originating from the English village of Cheddar in Somerset, England, and it is one of the most popular cheese with a global consumption of 21 billion kg yearly. There are several well-known companies that sell cheddar cheese, such as Bega, Cheesedale, and Kraft. The three main raw materials used in the production of cheddar cheese are raw milk, rennet, and starter culture. The purpose of rennet is to coagulate the milk into cheese curd, whereas the starter culture contains lactic acid bacteria such as the Lactococcus lactis subspecies Cremonis and lactis, which undergoes lactic acid fermentation to ferment lactose into lactic acid. So the rapid acidification helps in the coagulation and expulsion of moisture from cheese curd. In Malaysia, there are few farms to obtain the raw cow's milk, such as Desa Cattle Dairy Farm in Kundansang, Sabah, and Zaman Dairy Farm in Bentong, Pahang. The raw milk should be obtained from local or closest farm for the freshness of milk, thus ensuring the flavor of cheese. Starter culture for cheddar cheese can be obtained from online marketplace and are sold in powder form. For example, Gate Cheese Incorporated sells MA series starter culture for $12.95. In addition to that, whey from the first batch can be used as starter culture for the next batch. Moreover, rennet is also sold in local and online marketplace such as The Cheesemaker in solution and powder form both. In solution form, its strength is of 10,000 to 15,000, meaning for one part of rennet, it can coagulate 10,000 to 15,000 parts of milk. For the powder form, it is typically 10 times stronger than the solution form. The estimated cost operation to start up a cheddar cheese company is $267,248 to $623,874 for an annual production volume of 3,402 and 27,216 kg respectively. This, however, differs based on the equipment size, production volume, type of raw material used, and so forth. The equipment cost has a significant impact on the total cost operation, with an estimated cost of $261,974 for a 33,804 kg cheddar cheese production, which is equivalent to $1,224,073.51. Now I would like to pass on to the next presenter.
Thank you, Jamie, for the introduction. So I am Zeshuen. Now I will present the overall process of the cheddar cheese production. So as you see in the diagram, this is our process flow sheet. In general, cheddar cheese production include the preparation of starter culture, pre-treatment of pasteurized milk, coagulation, cooking, and cooking for upstream process to produce cheese curd and cheese whey. For downstream processing, it involves draining of cheese whey and production of cheddar cheese by cheddaring, moulding, pressing, ripening, and storage. Cheese whey will be our waste product. For upstream processing, the raw material used is pasteurized milk, and the starter culture which our microbe use is lactobacillus species. Milk pretreatment will be done by calculating the ratio of fat to protein in milk. After that, the pasteurization milk is done to prevent the product defect of growth of microbe in the milk. After this preparation, there are three main steps which are the acidification, coagulation, and dehydration process. This material will be added into the cheese vat for coagulation of the cheese. Rennet enzyme and calcium ion will play the role in the coagulation metabolism that consists of two phases, primary phase and secondary phase. Okay, after coagulation, the solidified cheese curd is formed, and then dehydration is occurred through cutting, cooking, and stirring by using the horizontal and closed rolling tank that you can see in the diagram. Finally, the cheese curd and cheese whey are formed. Draining of the cheese whey will be carried out by continuous domestic drainage system that will be explained by Adam Wismeyer, which you can see in the diagram. Cheese curd will be go to the downstream process to produce the cheddar cheese, while cheese whey will go to the waste management. Upstream processor will be presented by Samkaye and Najiha. For downstream process, the key process is cheddaring, while to form the cheddar cheese, rather than other type of cheese such as mozzarella, cream, and Parmesan cheese. So, cheddaring will change the physiochemical structure of the cheese to form the semi-hard property by using the cheddaring machine, which consists of 4 compartments that you can see in the diagram. Salt will be added into the curd in this machine to give the taste of cheese. The curd will be molded and pressed overnight up to 2.7 kilopascal by a conveyor press system that you can see in the diagram. Then ripening of the cheese will be using the starter culture and non-starter culture, which are the micro, to inducing the characteristic texture of the cheddar cheese and inducing the growth of microbe in the cheese. So there are three main metabolisms occur in the ripening process, which are glycolysis, picolysis, and lipolysis. Lastly, our cheddar cheese will be stored at low humidity and low temperature environment. This downstream process will be explained detailed by Susan. Okay, lastly, for the cheese vein management, the cheese vein will be used as a substrate by the mucoindices species, which are one type of fungi to produce eco-friendly packaging polymer and biomethane gases. And this process is using the bioreactor system. This management will be discussed by Adam Ismail in detail. So that's all for my part. I will pass to Sang Kayen for upstream processing. Thank you.
Morning, Doctor. I will explain about several parts of the upstream processing of cheddar cheese production. Then the following will explained by other members. Before the processing of cheese, we need to identify which types of milk are used throughout this process. The cheddar cheese is made from pasteurized lactose-free milk as the cheese produced contains a low level of lactose compared to using the regular milk. It is suitable to consume by someone who is lactose intolerant. The first step in cheddar cheese processing is milk pretreatment. Fat to protein ratio and fat in dry matter concentration need to be standardized to determine and control the cheese moisture and amount of fats and proteins. The legal minimum of fat in dry matter in cheddar cheese is 50%, while the maximum moisture content is 38%. Casein is a protein found in the milk that gives milk a white color. Hence, fat to casein ratio mostly used to determine the ratio of fat to protein. The fat to protein casein ratio can be modified depending on the ratio required by changing the content or quantity of the fat. For an example, if the initial fat or protein composition is lower than expected, it can be increased by adding skim milk or cream and removing fat through natural creaming or centrifugation when it is excessive. Next, we'll move on to the lactose-free milk production. Milk will undergo pre-hydrolysis where the soluble and immobilized lactase is added into a tank of raw milk to hydrolyze lactose into glucose and galactose. During this process, it will take 24 hours incubation in 4 to 8 degrees Celsius. This is to inactivate the microbial growth and avoid contamination since the milk is not sterilized yet. After the enzymatic treatment, the milk is heated to inactivate the lactase enzyme to prevent the continuous breakdown of lactose during storage. There are some purification methods involved to remove enzymes and impurities in milk. One of the methods is ion exchange chromatography to purify the lactose-free milk, removing any residual enzymes and separate proteins, lactose, and minerals. While the membrane filtration techniques such as microfiltration or ultrafiltration are employed to remove any solid particles or undissolved components in the milk after enzymatic treatment. Finally, evaporation is carried out to concentrate the lactose-free milk by removing a portion of the water content. This step helps to achieve the desired composition and viscosity of the final product. The high water content, nutrient pH, and essential nutrient content inside the milk, it has become an ideal growth medium for the microorganisms. Hence, pasteurization is needed to prevent the product defects that result from the growth of coliform or lactic acid bacteria. The milk has adjusted to not less than 63 degrees Celsius for 30 minutes or 72 degrees Celsius for 15 seconds. The low temperature long time method, which is 63 degrees Celsius, maintains the nutritional content in the milk. Hence, it is commonly used for making cheese and yogurt, while the high temperature short time, even though it can increase the time effectiveness, but it will slightly affect the nutritional content of milk and fails to destroy spore-forming bacteria. The heated milk is transferred to the cooling system, and the addition of carbon dioxide and nitrogen flushing into the headspace of the milk-containing vessel could extend the shelf life of raw milk since it would inhibit lipolytic and proteolytic enzyme activity and reduce the number of bacterial growth. This is the example of the pasteurization process based on the solar panel system. That's all from me. Thank you.
Assalamualaikum and hi everyone. My name is Najiha and now I will explain about the coagulation of cheddar cheese. Milk is treated and then poured into big vats. These vats can be different shapes and sizes, holding anywhere from a few hundred to tens of thousands of liters. To turn milk into cheesecake, we need to coagulate it. This is like making pudding, but using an enzyme called rennet. There are different types of rennet, some made from animal sources such as cow stomachs and others made from plants or microbes. When rennet is added to milk, it cuts the casein protein, which is the main protein in milk, into smaller pieces. These pieces stick together because of the calcium ions and it will form a gel network. And that's our cheese curd. The leftover liquid is called whey. Water, lactose, minerals, and serum proteins lost in the whey, while fat droplets retained in the cheese matrix. There are two phases of the coagulation process, which are primary phase and secondary phase. The primary phase is the hydrolysis phase, where casein protein is hydrolyzed to form a para-casein molecules and release short peptides known as casein macropeptide. And this para-casein will enter the secondary phase. The para-casein structure are coagulated by hydrophobic interactions and calcium bridges to form the gel network to each other, which is the cheese curd. Now let's move on to the next step, which is curd cutting. The coagulated mass can be cut once it has solidified enough. For each type of cheese, a specific cutting knife size is selected. The amount of moisture retained in cheese varies with the curd size. Large knife with about 2 cm are used to cut cheeses with high moisture content. This is because large curd is more likely to break, which makes it more fine, and less fat and non-fat milk solids stay in the cheese. Meanwhile, small knives about 1 cm are used to cut cheddar. Low moisture is caused by the curd's small size, which resemble rice grain. Small curd cheeses tend to have a more significant recovery of meat solids. As you guys can see in the slide, there is the tank that been used to cut and stir the cheese. Okay, now the important phase in making cheddar cheese is cooking. The curds are cooked and stirred after they have been cut with the same equipment of coagulation and cutting as shown in the slide before. In this phase, the curd temperature is gradually raised. For conventional cheddar, this is typically done to a temperature 38 until 40 degrees. The three methods of heating, which differ according to the type of cheese, include adding hot water to the curd or whey mixture alone, adding steam to the jacket alone, or using both methods simultaneously. So, in the case of cheddar cheese, it is cooked by steam in the jacket. As the curds cook, they get a bit more acidic, which also helps with the liquid separation. This cooking process is important for controlling moisture in the final cheese, affecting its texture and shelf life. That's all from me. Thank you.
Assalamualaikum and hi, my name is Adam Ismail and I will be presenting the draining part in the downstream process. So in the downstream process, the first thing we will do is draining the cheese curd to separate the cheese curd and the cheese whey. So firstly, the mixture of cheese curd and whey will enter the buffer tank labeled by number 1, as you can see. And then the small amount of whey removed upon the storage, and then the mixture will pass through the whey inlet using pump. And as you can see in the pictures with labeled, number 3 is the whey, where the whey inlet are located. And then the curd will remain at the bottom, whey will be filled up until it reaches the whey outlet. The whey outlet is labeled number 6 and 7 in the pictures. So upon reaching the level of the whey outlet, the whey will be removed through sieves perforated in a cylindrical wall, and it will be discarded via the whey outlet.
My name is Susan and I would like to introduce a downstream process. In downstream process, the cheddar cheese production is starting from the cheddaring. Cheddaring is a process that changes the physiochemical properties of the cheese. Non-starter culture microbes hydrolyze lactose to lactic acid. High concentration of lactic acid lower the pH level of cheese. This causes the micellar casein phosphate to be solubilized into calcium ion and phosphate ion. The increasing of concentration of calcium ion causes the hydration of para-casein. Therefore, there are formation of curds which are cheddar cheese. The cheddaring takes place in the cheddaring machine we call conveyors. This machine is a combination of cheddaring and sorting. The diagram shows the function of each part from feeding until the curd formation and sorting. Moving on to each conveyor activity, the first conveyor is to form the curd and further remove the whey. Next, matting and fusing process takes place to form the mat of cheese. After that, the mat will be inverted to allowing cheddaring. For the last one is held in the sorting process. Okay, let's move on to sorting process. In cheddar cheese, we choose to use a dry sorting method. The condition for the cheddar cheese after sorting are the water activity will become 0.95, salt concentration is around 3 to 7%, and the pH will be 5.3 to 5.6. As I mentioned before, the sorting was operated in the cheddaring machine. So how it works? The dry crystallized salt will spread on the small curd on cheese during the flow of conveyor. The curd of cheese will absorb the sauce and is called mellowing. Sorting is a crucial step in cheddar cheese production because it gives sorting taste, and whey removal. The reduction of water activity also improves the shelf life of cheese. The next part is mounting and pressing. For mounting, we choose to use a broad former. The height for the broad former is 7.5 meters. It's able to produce up to 1,000 kilograms of raw cheese each hour, and each of raw cheese is around 18 to 20 kilograms. The broad former operates by applying vacuum to draw out the cheese to broad. For pressing, there are some considerations which include time, temperature, fat content of the cheese, and cheese dimensions. Based on the findings, the optimum pressure to press the cheese is 2.7 kilopascal. Pressing also helps to remove the final whey. The diagram shows the broad former of the cheese from feeding until the broad form. The next diagram shows the equipment for pressing, which is a conveyor place. Next, we will focus on the ripening and storage. For ripening, it helps to induce the flavor of cheddar cheese, so the starter culture and non-starter culture are added. The microbes from both of these cultures will induce the ripening process. There are three metabolisms happen, which are glycolysis, proteolysis, and glycolysis. During glycolysis, the lactic acid bacteria in the starter culture will ferment the lactose into lactic acid. The lactic acid production will give acidic taste. For the cheddar cheese, for proteolysis, the protein will be broken down to amino acids. For example, tryptophan, tyrosine, and phenylalanine to form aromatic flavors. However, the lipolysis will give a final flavor to the cheddar cheese. Triglycerides will be broken down into fatty acids. These fatty acids will form ester compounds, and this make an ester flavor. The optimal condition for ripening is humidity must be less than 80% and the temperature is allowed 4 to 8 degrees Celsius. The diagram shows the overall metabolism during ripening, which start from the lactose and caseins. For storage, the cheddar cheese is stored in low temperature condition, which is around 4 to 8 degrees, and the air circulation must be flexible. Besides that, the humidity should be less than 80%. The ripening process occurs during the storage, so cheddar cheese ripening can take 8 to 10 months.
So I will explain in detail about the waste management of the cheese whey. So what actually happened to the cheese whey? So in our report, in our cheese production, we will use the cheese whey for the food packaging and the biofuel production. So during the cultivation of the fungal, cheese whey will be used as the medium optimization for the fungal to grow. And then the crude cheese whey will be diluted into half of its concentration, and the inoculation of the cheese whey will be done directly on the prepared plates. So the direct plating as well as the saturation using the distilled water will be performed. After cultivating the fungal will go through the extraction using the suitable filtration, washed, dried, and collected for future use and analysis. And then the protein acting as the main constituent of the fungal biomass will be measured, and then the collection of chitosan from the fungal biomass will be done. However, for the biofuel production, the liquid produced in the fungal cultivation will undergo the anaerobic digestion to produce the biofuel. Here are the few process or steps that we will need to understand in order to produce the biofuel. So the first step is the bioreactor will be filled with the inoculum and the fungal cultivation in the ratio of 2 to 1. And then the cultivation will be done using the dark serum bottles as the bioreactor. The gas generation will be measured using the control bottle, and then the bottle purged with the nitrogen gas and incubated at 37 degrees Celsius with manual shaking twice a day. So the last steps is where the biogas or the methane vented out from the reactor headspace, which caused by the anaerobic digestion of the fungal.
Lastly, the conclusion. We can conclude that the three main raw materials needed in cheddar cheese production is the raw milk, rennet for coagulation, and starter culture for lactic acid fermentation. Our group has also provided an overall insight into the production of cheddar cheese. The upstream processes involve the addition of starter culture and rennet, and milk treatment, followed by coagulation, cutting, and cooking. The downstream processes involve whey drainage, cheddaring, molding, pressing, ripening, and finally storage. In addition to that, whey produce can also be further bioprocessed to produce biogas and bioplastic,